Welcome once again to my YouTube channel. Today we are taking a topic from physics, moment of a force. Moment of a force is the turning effect or rotational effect of a force. Mathematically, it can be defined as the product of force and the perpendicular distance from the point of action of the force. We have this. Here is a turning point. Now here is just maybe a meter rule where we have mass inclined through this very string. Now this has to exert a force. Now the distance of this line of force from this turning point is what we refer to as what? The perpendicular distance, because it lies at angle 90 degrees with this line of force. So the moment of a force is the product of this very force times the perpendicular distance. The perpendicular distance D. From this very turning point to the line of action of the force. That is the moment. Now let's get into the principle of moment. The principle of moment states that the total moment acting at a point must be equal to 0. It can be stated in this very case. The clockwise moment of a force equals the anti-clockwise moment of a force. Now we have the turning point. From here we have a meter rule inclined on it. So if we have a mass, let's say here is M1, we have another mass, then here is M2. Now this M1 will exert a moment from this very turning point. And so we have the distance D1. Then we also have here the distance D2. Now this moment of this very M1 from this turning point could be stated in this way. That is, moment of M1 is equal to the force of this M1 times what? The distance of it, which will give F1 D1. Then we also take the moment of M2. The moment of M2 will now be the force of that body here times the distance of it, which will give F2 D2. Now looking at this, when you exert a little force here, the body will tend to move in this very direction, which we termed anti-clockwise moment. So if you depress this very one, it will tend to move in this very direction, which is clockwise direction. So at this very point, you will now see that the moment of M1 is anti-clockwise, while the moment of M2 is clockwise. So the moment of M1 must be equal to moment of M2. That's the principle of moment. So it's from the principle of moment. So we now have F1 D1 equal to F2 D2. Now let's apply this in solving. A uniform beam AB has a length of 60 cm and the weight 200 Newton rests on two supports P and Q, placed 10 cm from each end of the beam. Weights of 100 Newton and 80 Newton are placed at A and B respectively. Calculate the reaction at P and Q. So solution to the exercise, a uniform beam AB. We have a uniform beam, point A and point B, has a length of 60 cm. So if you take the length starting from 0 cm to 60 cm, so the length is 60 cm, and it weighs 200 Newton. Now the weight of the body acts at the center. Reason is because the body is uniform. So the beam is a uniform one. So the center of gravity is that very point where the weight of the body acts most. So where the weight, which is 200 Newton, acts most, will now be at the center, and the center of 60 cm should be 30 cm. That's the midpoint. So the midpoint here will be 30 cm. Okay? So the weight of 200 Newton will act from this 30 cm. The weight or the body rests on two supports, P and the Q, placed 10 cm from each end. So 10 cm from each end, here is 0, maybe somewhere here will be 10 cm. Okay? So we have the weight, P, then next is another 10 cm. So if here is 30, 40, 50, 10 cm, right, from the end. Let's subtract 10 from 60. So maybe we have here to be 50 cm. So between 50 and 60 cm will give us 10 cm. So we have another support, which is Q. Now, the moment you place these two knife edge, there will be a reaction to this very what? B. Because in every action, there must be a reaction from Newton's third law. Now, the weight 200 Newton has acted. Then there will be a reaction from this very point. So we are going to have reaction at point P. We also have a reaction at point Q. So because of the action, there must be a reaction. Weight of 100 Newton and 80 Newton are placed at A and B respectively. Now at A, we have a weight of 100 Newton. Then at B, we have a weight of 80 Newton. Okay? Now calculate the reaction at P and the Q. Now we are asked to find the reaction at P and the Q. Now we have the reactions as the upward forces, while we have 100 Newton, 200 Newton, and the 80 Newton as the downward forces. Now, the downward forces, if you sum it up, it must be equal to all the what? Upward forces, because action and the reaction are equal and opposite. So the actions, which we have 100 plus 200 plus 80, must be equal to RP plus RQ. So we have RP plus RQ must be equal to 100 plus 200 plus 80 Newton. Okay? So here we have RP plus RQ. If you sum it up, it will give what? 380 Newton. Maybe you call this equation 1. At this point, we have to get the moment of each and every forces that we have there. We have 5 forces acting at a point. We have 100 Newton, 200 Newton, 80 Newton, RQ, and RP. Now, to get the moment of each and every forces there, we have to neglect one of these supports. Maybe we neglect this very Q. We neglect that very one and work with this very turning point. Or you can as well neglect that of Q, or that of P, and consider what? Q as the support there. So once you neglect this, then we work with this. Now we are going to get moments of each of the force. Now we have moments of 100 Newton from the turning point, from P. Now, at this point, I would like to use a symbol for moment. I will be using this. Moment. I will be using this to represent moment. Okay? Okay? So, at this point, let me just take it in this way. Moment of 100 Newton from P. So moment of 100 Newton from P will be the 100 times the distance of P. Okay? Now let's get the distance of that 100 Newton from P. Difference between 0 to 10 will give us 10 cm. Okay? So the perpendicular distance now is 10. So the moment of 100 Newton from P will be this 100 times 10 centimeter. Okay? Here is 100 Newton, while here is 10 centimeter. So if you multiply both, it will give 1000 Newton centimeter. Okay? That's the moment of 100 Newton. Now check the direction of 100 Newton. Now it moves. That should be anti-clockwise, right? Anti-clockwise. So the direction now is what? Anti-clockwise direction. Now let's get the moment of 200 Newton. Now the moment of 200 Newton will be 200 Newton times the distance from the turning point. Okay? So we have 200, the distance. Difference between 30 and the 20 will give 20 centimeter, right? So times 20. So at this point, we are going to get 4000 Newton centimeter. So that's the moment of 200 Newton. Then let's get the direction of it. The moment has this direction, it's moving in this way, so you measure it from the turning point. So that should be clockwise, right? So we have it to be clockwise direction. Then we also find the moment of 80 Newton from P, okay? Now from P, get the distance of it from P. So at the point P, we have 10. At the point of B, we have 60. Difference between 10 and the 60 will give what? 50 cm, right? So the moment of 80 Newton from P should now be 80 times 50. So we have 80 times 50 cm. So 80 Newton times 50 cm. 8 times 5 will give 40, right? So we add 2 zeros. So we have Newton meter. So this is the moment of 80 Newton. Now, check the direction of it. In this very direction, it moves. That should be what? Yes, clockwise. So we have it to be what? The clockwise moment. Now, what about the moment of RQ? Now, it should be from the turning point, that's it, from P. So we have it in this way. The distance, we need to get the distance first. This point is 50, while here is 10. Difference between 50 and 10 should be 40 cm, right? So it should be RQ times 40. RQ times 40 will give us what? 40 RQ, right? So that's the moment. Now let's check the direction. At this point, you see the direction. So that should be anti-clockwise. So we have the direction as what? Anti-clockwise. What about the moment of RP? Now RP, it should be RP times its perpendicular distance. But the RP is at that very point, P. So in that case, it has no moment because there is no perpendicular distance. So the moment is 0. It has no moment. Okay? Now, So you remember the principle of moment, you have to sum up all the clockwise moments, you sum up all the anti-clockwise moments. And the principle of moment says the anti-clockwise moment must be equal to what? Clockwise moment. Now let's get the sum of anti-clockwise moments. Okay? Then we have the anti-clockwise moment, 1000 Newton centimeter. Let me add up first. Anti-clockwise, we get another anti-clockwise plus 40 RQ, all measured in what? In Newton centimeter, okay? Then we also get, let's simplify this first. 1000 plus 40 RQ will still give us the same thing. So that will be the result. So we get to sum of clockwise moments. Now, the clockwise moment, the very first one we have 4000 Newton centimeter. Another one, we also have 4000. So in Newton centimeter, right? Then if you sum it up, it will give us 8000 Newton centimeter. This one is what? The sum of anti-clockwise. Now, from the principle of moment, you remember from the principle of moment, the anti-clockwise moments, okay, must be equal to what? Clockwise moment. And we've got the sum of anti-clockwise moments as 1000 plus 40 RQ, which will now be equal to 8000. Now, you remember the units. The unit of this very one is Newton centimeter. The unit here is Newton centimeter. They will cancel out. So in that case, we make RQ the subject. If 1000 should cross a quality sign, then we have 40 RQ equal to minus 1000, right? So 40 RQ will now be 8000 minus 1000 will give us 7000. Now divide both sides by 40. This will cancel out. So what will be the value of RQ? So we are going to get 7000 divided by 40. That will give 1075. RQ is a force now measured in Newton. Now, you remember where we got the relationship between RP and the RQ, which is equal to 380. Hence, we can now get what? The value of RP. So we now said, but RQ plus RP is equal to 3800 Newton. Now let's do the substitution together. Let's do the substitution. So if you substitute now, RQ, we've got the value of RQ as 175 Newton, right? Where we said that RQ plus RP is equal to 300 Newton. Now, if we do the substitution, RQ, we substitute here 175, then RP, which is equal to 38 Newton. Now, 175 should cross equality side. We have 380 minus 175 Newton. Then if we simplify, 380 minus 175. So our RP now becomes 205 Newton. And that gives what? The reactions. So in that case, the RQ is 175 Newton, while RP is 205 Newton. We have another question on the board. It reads, a uniform rule is balanced at 40 cm mark when a body of mass 50 grams is suspended at 8 cm mark, the balance point is found to be at 40 cm mark. Calculate the mass of the meter rule. The distance of the balance point from zero end if the body were moved to 15 cm mark. Now, a uniform meter rule is equivalent to 100 cm, 100 centimeter rule. Okay? So, a uniform meter rule ranges from 0 cm to 100 cm. Of course, the center of mass should be at the midpoint, which is 50 cm. But from the question, it reads that the uniform rule is found to balance at 46 cm. So the center of gravity is 46 cm, while the center of mass is 50 cm. The center of mass is the midpoint of the body, while the center of gravity is the point at which the weight of the body acts or appears to act. So the center of gravity is where you are to measure the mass of the body or the weight of the body. So at this point, the balance point is 46 cm. So if you want to get the mass of the meter rule like it was asked, it must be at 46 cm, not at the center of mass, but at the center of gravity. So the mass of the body acts at the center of gravity. So M is the mass of the meter rule. Now, when a body of mass 50 grams is suspended at 8 cm mark, so when a body is suspended at 8 cm mark, 8 cm mark should lie between 46 and 0. So maybe we have it here, 8 cm mark. So when a mass of 50 grams, we have a mass of 50 grams, is suspended at 8 cm mark. The balance point is found to be 40 cm mark. Now, the balance point is found to be 40 cm mark. 40 cm mark should lie between 8 and the 46. So we have the balance point at 40 cm mark, okay? Now, calculate the mass of the meter rule. Now, at this very point, we are going to get the moment of 50 grams and the moment of M. Okay? Now, at this point, I will be using rho to represent moment of a force. So, at this point, we look for moment of 50 grams. Now, the moment of 50 grams, will be 50 grams, okay, times the distance from the turning point. The distance here is the turning point. So it should be difference between 8 and the 40, which will give 32 cm, okay? So it should be 50 grams times 32 cm. So if you multiply this, the 50 times 32, so it will give 1,600 grams cm, okay? Now check the direction of it. You see the body moving. The rotation of it should now be what? Anti-clockwise. So we have this one as what? Anti-clockwise moment. Then we also check the moment of M from that same turning point. Let's get the distance there. So the distance will be the difference between 40 and the 46, which will now be 6. So here we have moment of M will now be M times M we are looking for the value of M now. So M times, we have 46 minus 40, we get 6 cm, right? Now, if you multiply this, you are going to get M or 6M centimeter, right? Now, check the direction of it. So it should be clockwise moment. So this one is what? Clockwise moment. And from the principle of moments, we have the anti-clockwise moment must be equal to clockwise moment, right? So if clockwise moment is equal to anti-clockwise moment, then we are going to have 6m centimeter is equal to 1,600 gram centimeter. Now the centimeter will cancel centimeter. Then you divide both sides by 6. So here you are going to have m 1,006 gram divided by 6. So if you do that, then we are going to get m to be 266.67 gram. So this gives the mass of the body. Then the next question says, calculate the distance of the balance point from 0 end if the body were moved to 15 cm mark. Now, if the body were moved to 15 cm mark, okay, let me wipe this. Now, we've got the mass already. We've got the mass of the body to be 266.67 gram. Okay? So at this point, calculate the distance of the balance point from 0 end if the body were moved to 15 cm mark. Okay? Now the body is 50 gram. We have the 50 gram. Here is 0. Then here is 100 cm. Now if this very mass we are moved to 15 cm, 15 cm, 50 gram moved to 15 cm mark. Okay? Now calculate the distance of the balance point from 0 end if the body were moved to 15 cm mark. Remember, we have the mass at 46 cm mark, right? That's the mass of the body, which is 266.67 gram, right? So at this very point, the center of gravity will no longer be 40 again because of this very what? Change in distance of 50 grams. So you have to adjust this center of gravity. So what is the distance of this center of gravity from the 0 point? That's the question. Okay? Now, if the distance is x from the 0 point, so what's the value of x? So remember here, x represents the distance of the balance point from 0 end. So here is the 0 end. Here is the balance point. Okay? So what's the value of x? So to obtain that, we get the difference from here to here. We have it as x. Already from here to here is 15. So if you now want to get the distance from here to here, it will now be the total length here minus this 15. So here now will be x minus what? Minus 15, right? Then what about the distance here? So in order to get the distance here, now you remember that from here to this very point is 100, right? Now, from this point to this point is x. Then from here to here, from 0 to this very point is 46. So in order to get this very point, we are going to take 46 minus this very x. So here now will be 46 minus x. Okay? So the distance here. So at this point, we get the moment of each of the masses here. So the moment of 50 gram from this center of gravity here, okay, will now be 50 times the distance now is what? X minus 15. So if you multiply this, it will give 50 x minus 15. Okay? That's the moment of 50 gram. Now, is moving in what direction? That should be anti-clockwise. So we have anti-clockwise moment. Then again, we get the moment of 266.67 gram from that center of gravity too. Okay? Then it will now be the mass times the distance, which will now be 46 minus x. So if we multiply this, it gives 266.67 times 46 minus x. And in this case, that should be clockwise moment, okay? So if this one is clockwise moment, then we have to now follow the principle of moment, which says that the anti-clockwise moment must be equal to clockwise moment. The value of x, then we employ the principle of moment, which states that what? The anti-clockwise moment is equal to clockwise moment. So at this point, anti-clockwise moment is equal to clockwise moment. Now, we have the anti-clockwise moment here, which is 50 in bracket x minus 15, okay, which will now be equal to clockwise moment. The clockwise moment is 266.67 in bracket of 46 minus x. So if we open the bracket, 50 with times x, we have 50x. 50 with times 15. So 50 times 15, we have 750. Then 266.67 times 46. 266.67 times 46. So we are going to have 12266.82. Then minus 266.67 times x, we give 266.67x. We collect the like terms. If negative of this x here should cross over here, we have it as plus 266.67x equal to 12266.82. If minus 760 crosses equality sign, it becomes positive. So if we add this up. So if you add this, you are going to have 130.16.82. Then add up this. Then we have 50 plus 266.67. So here we are going to have 316.67x. So divide both sides. Here you divide by 316.67, divide by 316.67. So this will cancel out. We have the value of x. So if you divide 130.16.82 divided by 316.67. So here we give 41.11 cm. Okay, so that's the distance from 0 point, 41.11 cm. So if what we did, we're able to help someone out there, please do subscribe, share, and turn on notification for others to learn as well. See you on our next class.